Okay, today we're going to work on operations with scientific notation. We're going to start out with working on adding and subtracting, and then I will do a separate video for the multiplying and dividing. The add subtract is going to get taped on page 105. The multiplying dividing will get taped on page 106 when you get them finished. Okay, first off, with adding and subtracting, if you have the same powers of 10, it's super simple to add and subtract values. What you do is you simply add or subtract the numbers that are out front, and then you just have to keep the same power of 10. And this works because you end up having the same number of place value digits as both numbers, so you can just add what you have and keep the power. If you have different powers of 10, that becomes an issue. So what I typically recommend students do is rewrite one of the numbers, giving it the same power of 10. Or you can always just convert the values to their standard notation, line up your decimal points, and then once you get your answer, rewrite it in scientific notation at the end. Most students prefer this method rather than trying to rewrite it to have the same power of 10. So we'll go over both ways. So at the beginning, we see that we have this number times 10 to the 8th plus this number times 10 to the 8th. And like we said before, if they both have the same power of 10, that means they have the same number of exponents. So what you will do is, or the same number of place values, excuse me. So what you're going to do is you're just going to combine the number that are out front. So 6.2 plus 2.3 is just going to be 8.5. And because they have the same number of place values, they're also going to have the same power of 10. So we're going to keep the power of 10. We're going to add our numbers out in front. And as you can see, we still get 8.5 times 10 to the 8th. The next question is just subtraction. We have 9 minus 4. We have the same powers of 10 in both examples. So this allows us to just subtract the numbers out front. And it allows us to keep the same power of 10 that we were originally given. So 5 times 10 to the negative 3. The next question also has the same powers of 10, so again, we can just combine our numbers out front. This should give us 7.32. We're going to keep the powers of 10 because, again, that just represents the place value that we have. For number 4, you're going to see that the numbers were written in standard form. When they're in standard form, typically what you will do is you will line up the place values, line up your decimal point, and combine. When you do that, you do get 68 million. And if you looked at the directions, it does remind us to put our answers in scientific notation. So if you recall, you're going to go all the way over, you're going to take the digits, and you're going to form a decimal that is a value between 1 and 10. So we will put our decimal point here in between the 6 and 8. Then you will count your place value. You need to move it over 7 places, and that gives us our power of 10 times 10 to the 7th. This one here, again, we can line this decimal point up and we can lay our numbers vertically so that we can go ahead and do our subtraction easily. When you do that, you're going to get 0.000, and then you're going to get the numbers 112 from doing your subtraction. To write your answer in scientific notation, remember you ignore all the zeros. You come over here and we need to form a decimal between 1 and 10. So we need our decimal point right here, 1.12. You've moved it 4 places, so just remember, because you're dealing with a small decimal, it's going to be times 10 to the negative 4th power. Number 6, we have values to add together. You'll notice that we have the same number of digits, although if you line this up carefully, we can put a placeholder 0 back here, and then we can see that you're going to get the solution 0.0065. From 0.0065, remember you're going to write your answer in scientific notation, so you want your decimal between the 6 and a 5. You've moved it 3 places, so again, being that it's a small decimal, you're going to have times 10 to the negative 3rd power. On the back of your note sheet, we have given examples that are different place values. So my suggestion with these is to go ahead and write out what that number actually represents. If we move our decimal point times 10 to the 7, if we move it 7 places, moving it from the in between the 4 and the 7 over takes up 1 spot, which leaves us with 6 zeros. And what we're doing with that number is we're adding it to this number over here. We have 3.4, so if we move the decimal point past the 4, that leaves us room for 7 zeros. And if we have all of our digits in place and you combine, we can come up with 50,400,000. You know that it's helpful to have zero or commas in between every 3 place values, so that way you kind of keep track of what you have and if you have the right number of zeros. So if we do have this number as our solution and we need to write it in scientific notation, remember you're putting your decimal point so that we have a number between 1 and 10, so 5.04. We've moved the decimal point 7 place values, so that's why we're going to have times 10 to the 7th. In this example, again, we want to go ahead and write out what the numbers are in standard notation. 9 times 10 to the 5, since we have no other digits to move past, we do end up with 5 zeros. We'll put our comma in first this time. And this time we are subtracting 8 times 10 to the 4th, so that gives us 4 zeros. If you do that correctly, you're going to end up with 820,000. 820,000 needs to be written in scientific notation, so 8.2, and let's see, we've got 5 digits that we've moved over, so it's going to be times 10 to the 5. This next one is going to make sure that we remember how to use our negative exponents. This one has us multiplying by 10 to the negative 5, so we're moving in the negative direction 5 places. That means we have room for 4 zeros, and then we have to have our 28. We are adding to this 1, 2, 3, 4, 5, 6 place values over, if that says times 10 to the negative 6, like I think it does. And when we add, we should end up with 0.0000334. You can check that value on your calculator for me, and then you can go ahead and make sure when you write it in scientific notation, you're at 3.34, and you've moved it over 5 places, so that's a negative 5 because you're dealing with a small decimal. 0.0072 is the first number we have in our last example, number 10. 0.00068 is what we're subtracting from it. If we do that correctly, we end up with 0.00652. 0.00652 needs to be written in scientific notation. So we should have 6.52, and we should be able to write it as times 10 to the negative 3. The bottom of your note sheet on the back has a couple more practice problems where you're adding, and this time if they are in different formats, you have a choice. You can rewrite them like we did on the other page. This one, let's see, we've got to move it over 5 place values. So if we do, you see you're really just adding the number 640,000 to the 320,000 that they gave us. If you do that correctly, you know you're dealing with the number 960,000, and then we just have to convert 960,000 into scientific notation. So 9.6 times 10 to the 5. And I have too many zeros, so double check that. In this case, you probably want to stack the numbers on top of each other so that you can keep track of your place value. 1, 2, 3 zeros, and the 3, 2 for this one, 3.2 times 10 to the negative 4. This makes it kind of nice so you can do the subtraction. And I think you can see where we're going to get 0.00022. Converting 0.00022, you've got 2.2 times 10 to the negative 4. You read this one carefully. We're trying to use these two numbers and find the difference between the two populations. So the population of Eagleton is got 5, 7, and let's see, you'll need 4 zeros behind that. So 570,000. The other town only had 430,000. So if you set your subtraction problem up, it's going to look like this. You can subtract by hand, hopefully, and you can come up with 140,000. 140,000 converted is 1.4 times 10 to the 5. And for the last one, we're talking about paper that is very, very, very thin, so 0.025 millimeters. She's going to glue a layer of paper onto this construction board, and the paper is very thin. Also, it is 7 times 10 to the negative 2, so that's going to be 0.07 millimeters. And when you combine those two numbers, you're going to get 0.095 millimeters. So if we convert 0.095 millimeters, we have 9.5 times 10 to the negative 2. So again, this is your notes on adding with scientific notation. You can convert into standard numbers, do the math, and then convert it back to scientific notation. And again, this gets taped into your notebook on page 105.